we were talking about exponential growth and exponential decay functions. And here we have sketch a graph of y equals 1/2 times 3 raised to the x power. Then state the domain range of the function. Because we don't have any translation on the x or on the y, good points that we can always pick for this type of graph, we can substitute in 0 and we can substitute in 1. And so what we're going to do is just substitute that into the equation. So 1/2 times 3 raised to the 0 power. 3 to the 0 power is equal to 1. 1 times, this is 1/2. 1 times 1/2 is 1/2. Same thing, 1/2 times 3 to the 1. 3 to the first power is 3 times 1/2, and that is 3/2. And so we can plot those points. If we're going on a scale of 5, -5, -5, and 5. So 0, 1/2, and 1, 3/2, which is 1.5. Then because we don't have a k value, or in this case our k value is 0, we'll still have our asymptote is at y equals 0, and then we'll have a graph that comes up, and then we have exponential increase. And actually, if we plug in another point, which in this case we'll say 2 will be the next one, 1/2 3 squared, that's going to be equal to 3 squared is 9 divided by 2 is 9/2, which is 4.5. So 4.5 will be right there. And then we can graph to go through there. Then we take a look at our domain and range. And again, the domain for these is going to be -infinity to infinity. The range, in this case, our asymptote is y equals 0. So our range is going to be 0 to infinity, neither one included, so we use the parentheses. Asymptote, in this case, y equals 0, and the y-intercept is going to be right here at 0, 1/2. And we can take a look, and there we have the point graph, or there's the function. We have 0, 1/2, and then we have 1. We can get it. 1, 1/2, and then we should be at 2, 4.5. 2, 4.